Alright, now, let's come back. Propose arguments for and against the use of this particular concept. So I just gave you some, right? The length of time it takes to develop, because it just has to go through and try again, okay? But also the fact that it can learn is great, because not only can it actually adjust itself in response to what you know, but later on, once you've trained the system, okay, it can encounter new situations that you've never encountered before and make a prediction and recommend a decision on the basis of that, even if it's never seen it before, it's only had this expected data. Okay, and that's really, really good. That's kind of the idea of an expert system that we're trying to get at, right? Now, neural networks and expert systems, both designed by human software engineers, contrast the relationships between these two sets of designers. Okay. Now, we were kind of getting at this just now. How would you articulate the difference between them? Let's start with this. With these three, okay? The human designer, what kind of level of input do they have to the structure and function of the decision support system in these three cases? Lots. Can we be any more specific than lots? Because lots is accurate, but it's vague. Okay, yeah, they have total control. Total control. If there's something in one of these systems, it's because a programmer put it there. Okay? It's because you actually typed in the formula, or you designed the tables and their relationships, okay? Or you designed the knowledge base and how it would read the database of facts, and the inference engine, you chose it, backward chaining, forward chaining, and so on. Okay? So total control. Okay? Whereas the designer for an artificial neural network, right? What's their job? It's kind of like they're feeding an animal, right? All you have to do is give it data. Okay, now you do have to pick the right data, okay? So you've got to select that. You can't just give it anything, right? You want to give it a good set of data. But that's the different kind of relationship, right? So the real structure and function is actually being decided by the artificial neural network itself, okay? Now, that feeds right into number 4. Once you've got a neural network and it's trained up and it's good at making decisions, right? Sometimes it'll make a decision and the designer won't be able to explain why it made that decision, which is a big contrast to the expert system, which has its explanation mechanism, which is designed for that specific purpose. So, why not? How can that be? You know, the designer designed it, so how can they not be able to explain?
Decision making. It's like taking the average of inputs in life.
Okay, yeah, right. So
not logical. It's just it works.
It's almost like a brute force kind of approach, right? Okay, now let's go after that. The explanation mechanism. Do you remember? Let's see if we can revise this, because this is a bit trickier. The explanation mechanism, right? What data does it draw on to give its justification, to give its explanation? Where does it go? Okay, go back to your notes on expert systems, right? You need to know this one. It goes to all the other parts, and it takes particular bits of the other components of the expert system to explain. Number 1, it says, okay, look, the database of facts, right? It says, you gave me all these pieces of information. Maybe you gave me 100 pieces of information, but it was these 20 that you told me about that were really important to the decision I was going to make. Okay? So it goes to the database of facts, and it pulls out the relevant details for this situation, right? Okay? Do you remember that? Yes? Now, these relevant details, right, they interact with the knowledge base. What was in the knowledge base? Do you remember that? What does the knowledge base contain? Yeah, that's right. So it's got a set of rules that determine how it understands a scenario, right? And only some of them, the ones that relate to the details, right, will be activated, will be fired, okay? So it'll say, what were the relevant rules? Okay? And then, of course, it goes to the inference engine, right? And it says, okay, how did you actually execute those rules, and how does that actually explain what kind of decision you made in the end, okay? Now, therefore, once an expert system makes this kind of decision, it will present this as evidence, and it will say, look, see, this is exactly why. I'll tell you why I made this decision. It's because of this piece of logic that you put in me, right? Or this particular detail that's provided by the client. Okay. On the other hand, the neural network, right? What explanation is it going to give? Do you remember the structure that was illustrated, right? What you've got is your inputs on the left-hand side. Okay, by the way, this is a really important diagram that you need to get. You've got a few inputs here. You're going to get some outputs over here. And then in this in-between space, you've got all these nodes that are connected to each other, the artificial neurons, right? Because they're kind of doing this, literally, this sort of black magic sort of thing, which we don't really understand, that's why it's this weird sort of cloud, right? The hidden nodes. So the mechanics of this is not understood by the neural network designer necessarily, okay? Not only is it sort of doing its job to work out its weightings and its transfer functions on its own, but it might just be so complicated that even if a human did understand all the bits, they wouldn't be able to actually say, oh yeah, this is why, right? It's just so complex, just like a human brain is, okay? Sorry, I missed